just started, okay, how to build warehouse and what will be there in your warehouse. So that we in the data warehousing, okay, we are going to keep a lot of historical, okay, consolidated all the information, and the data which you are going to place in your data warehousing, we are going to use it for your analytical purpose. Okay, so that's why when we are going to create tables in a data warehousing, okay, how are we going to create, okay, tables in a data warehousing is a big question mark. So that is generally called as a, okay, dimensional modeling. Okay, and when we are creating tables in a data warehousing, we'll create the tables in the form of dimensions and facts. Okay, so what is the dimension and what is fact? Okay, we have seen very high level. Okay, now I'll just recap it what we have. Okay, so if you take any business which is running in the world, and always when you are trying to understand how your business is running, let's say if you go to any body shop, kirana shop, or if you go to any bank or an online shopping mall, if I want to know how my business is running, okay, so first of all I will find out, okay, so if which number is good, okay, then I can say that my business is running good. So yeah, let's say you have a family 10 members, okay, now you want to know what is your family strength. So how many family members are there in your family, so that will tell you what is your family strength. So what is your total bank balance? Okay, based on the balance, I can tell you how sound you are taking in the financially. Okay, so means always when you want to say something, we'll first to take some parameters. If that is good, then I can say you are very healthy, or okay, you are very rich, or based on that I can decide what is what. So here also when you are running a business, every time to gauge your business or to measure your business how it is running, so we'll list out some of the metrics. Okay, so here take one example of the online or a shopping mall. So to understand my shopping mall how it is running, so I'll tell how many number of orders are placed every day and what is the total price, okay, customers are paying. So if the total number of orders is big, means I can say my shop is running. Every day orders are increasing or my order number is more, then I can say that it is very big. And order price, okay, so if I'm getting more payments done by the customer, so I can say my business is running well. In the similar way, a tax, how much tax they are paying. So these are the metrics. Okay, generally whenever we are running a business, first of all we'll list out and identify, and these metrics, okay, to understand, okay, at different levels. Okay, now I want to know in which country, in which region or which state, okay, my business is running more, so that I can go and understand. I can, let's say there is one region or one country, the sales are very less, so I can go and talk to that sales manager and say your business is very dull, you do some promotional activities and then improve the business. So I'm looking the order quantity, okay, that number of orders only, but this time I'm looking at the region wise, country wise, state wise. Or I may want to know my shop, okay, is good for married people or unmarried people. What type of customers are buying more, okay, in our shop? So married people or unmarried people, or what type of customers, okay, whether it's a children's or old age parents, or like what type of, so what kind of people are very much attracted in my shop, so that I can improve, or I can, wherever I am low, I can go and further make it some different promotional activity there. And in the same way, sometimes I want to find out brand wise, okay, which LG, which kind of products are, okay, very famous for we, okay, LG are going well, or like Sony is going well. So it depends on that. If any, we'll try to keep more Sony products, or we'll try to keep more LG products, or year wise, quarter wise. So this quarter we have a target of reaching $1 million. Okay, but did we reach, okay, 1 million target? How far we have to reach? How much we are less? All that analysis. To do analysis, we are identifying some metrics. Okay, these metrics always we are looking at different dimensional attributes. Okay, that we did discuss about. Okay, this is, okay, all your customers and their address information, and this is all product information, and this is year date information, this is the channel information like internet or direct shopping mall, whatever it is. Okay, so now whenever we are, since we are this information we are going to dump into data warehousing, so always in data warehousing you try to dump the data, okay, into data warehousing, but you divide your data into two parts. Okay, So that two parts, one part is nothing but your red color and another part is nothing but your blue color. So whenever you are taking and then dumping data into data warehousing, you classify your data into two parts. One is all red color. Okay, red color will tell you how your business is running, and this red color information always I will analyze across different attributes whatever you have. Okay, region wise, product wise, date wise, and character wise. So not only this, you take any business in the world. If I want to understand how my business is running, so we will always have some red color and some blue color. If you go to bank, how many number of customers we have, how many credit cards we have, what is the total due amount from each and every customer, and all that information I want to find out. And this information I will look towards different angles. So that's why when you are keeping data into data warehousing, you divide into two parts, and you create tables for red color and you create tables for the blue color also. Okay, so these red color tables, okay, the information which are keeping, okay, the red color information, which is generally called metrics or measures. Okay, and why we are calling as the measures? This information is going to help you to measure your business. Okay, so how my business is running, it is helping you to measure your business. That's why the tables, okay, which are going to have your measures information or metrics information or the quantifiable information is called fact table. Okay, because it is going to give you factual information about your facts about your business. Okay, because it is really telling you whether you are running good or not. Okay, that's why. So these tables, okay, the tables which contains the measures information or quantifiable information or a metrics information, anything whatever you call, and which are called fact tables. And the other tables which are going to keep these blue color ones are called dimensions, because so these are all attributes, product attributes, okay, date attributes, customer attributes, and then the channel attributes. Okay, so what is attribute? What is the dimension? The English meaning is attribute. Okay, let's say you have a product. What are the attributes or what are the dimensions of the product? Or there is a, okay, pen. What are the dimensions of the pen? Means what is the brand name of the pen? What is the manufacturer of the pen? What is the size of the pen? Okay, all these are all attributes or dimensions of your pen or like product. So that's why. So all these tables are known as called as a dimension tables, and this is called fact table. So blindly remember, whenever you are building a warehouse in the globe, not only one or two, small, big or anything, when we are loading data into data warehousing, first I will decide data into two pieces. One piece is this kind of information, other piece is the dimension information. Then I will create one table for one dimension and one table for the fact table. Okay, so once we load the data into, once we divide data into this way, one problem will be I cannot relate one table to other table, because as per the it is a table. So in a relational database standards, okay, we need to, in order to join one table to other table, because I want to know, so this customer, okay, this product, okay, this, there is a two quantity of the product purchased. So who is the person, okay, bought this product? So there is no relation here. So that's why when we are loading data into fact table along with the measures, the metrics or whatever we have, so we'll also keep, okay, foreign keys of the dimensions. Okay, so this is the product quantity. So who purchased it? Okay, what is this product? Okay, this product is P001, means it is a TV. Okay, it is LCD, brand Sony. Okay, category is electronic. So who purchased? Customer C1. Okay, C1 John. Okay, is a male, and what is the address? Okay, and which date he purchased it? Okay, on the 2012, and whether he purchased online or offline. So he purchased, okay, CH1 means it is the internet, means he purchased online. So this is how you can combine the data which is there in the dimension fact table along with the dimension, so that you can, any question if I ask you, can you please tell me how many quantities sold out in a Sony brand? So I'll join this table and this table, okay, based on this column. And if anybody asking, tell me in region wise how many quantities sold out, I will join these two, okay, this group by region, okay, count of custom quantity or sum of the price. So I want to know how many quantities sold in internet or direct, offline, online. So join these two. So So every year wise, quarter wise, month wise, week wise, anything I can get it. Okay. So somebody will be looking day wise, somebody will be looking, or somebody will be looking year wise, day wise. It is of your choice. If I have the information, you can get whatever you want. Okay. So this is how we build the tables, and this model is called star schema, because I have a one fact table sitting central and all other dimensions surrounded. Okay. So 1, 2, 3. You can have even 2, 3 more dimensions also. It is not like always we should have only 4 dimensions. The dots indicate that you can have n number of dimensions. Okay, but all the dimensions should directly join with the fact table. Okay, that is called star schema. Okay, so technically, how you can define a star schema? Diagrammatically star, because I have a focal point in the fact and then all dimensions are surrounded. But technically, how we can define this is every dimension table. If you take dimension, 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 so these dimensions, okay, they do not have any child. It means that every dimension table is fully denormalized. Okay, and one central point is fact table, other all dimensions. So every dimension, okay, we don't have any other dimensions outside. Okay, we don't have any other tables. It is all a fact, one central point, and all other dimensions are there directly joined. Okay, that's why. So this is called star schema, because framing a star diagram. And technically, how you can define a star schema? Star schema is not in star schema. All the dimension tables are fully denormalized. That is the technical word. Okay, because this will be the first interview question in a data warehousing. Okay, what is star schema? Okay, how you build? Okay, and what are the other schemas and what are the differences? Okay, so now here we have the customer table. Okay, so now here, what is the logic here is when I say customer all the dimension tables are fully denormalized. So here I have a customer table. So all the customers, okay, and their address information, all I am keeping into one table. But product table also I am keeping into one table. But at the same time, I can also, when I am building the tables, I can also normalize the dimension table to some extent. Okay, so I have a customer dimension table, and this customer dimension table I can also split into 2 tables. I have a product dimension table, I can also split into 1 or more than 1 or like 4, 5 tables. Okay, means I can also, when I am creating my tables, let fact table be there as it is, but these dimension tables I can combine into one table, or I can also split into multiple tables. Means normalize the dimension tables. So normalization, we know normalization is nothing but splitting your bigger tables into smaller tables. Okay, I can also split this customer. Previous diagram was customer, all the information into single table, but in this diagram we have customer and then these 2 tables are separately split. Okay, not only that, any other tables I can split. So in this diagram, sales is one fact table, remaining customer dimension, time dimension, and here I have split the market dimension into 3 tables. I have split the product into 2 tables. Okay, like this you can split any table to any level. Okay, so when you split your dimension tables, means technically when you normalize your dimension tables, okay, your diagram will be looking like this, and this kind of technique or modeling technique is called snowflake. Okay, previous one is star. Okay, one central and all the dimension, and 1 to 1, 1 to 1 like this, and that is called star schema. And now it is a snowflake. Okay, because fact table and dimension tables, and technically how you can define star or snowflake. Star schema, all the dimensions are fully denormalized. Snowflake, your dimension tables are normalized to some extent. To some extent, why I am using? Sometimes I can split, okay, this into, if you see here, one dimension joined this, but if you see there, one dimension, it's split into another table, that again got into another split. So to some extent you can normalize. Okay, that's why it is called snowflake model. So finally, when you build a warehouse nowadays, either you will have a star or snowflake, but nowadays you will see mostly snowflake. Okay, so when you put these stars or snowflakes together, we know what is star. Star means one fact and other dimensions, and snowflake means your one fact may join with dimension, further dimension will with other smaller tables. And when I put star or snowflake together, so this is called multi-star. So let's say this is one fact table, so this is another fact table. So this is joining with their dimension, and this is joining, okay, there are some common dimensions for both and all. Okay, this is called multi-star. Also sometimes called as a galaxy, multi-star galaxy. It is, so generally that is not a, multi-star is not a important. What is important is star or snowflake. Putting together stars or multi-stars is anyway multi-star, okay, or also called galaxy, okay. But technically from the interview point of view or from the understanding point of view, what is important is star snowflake. Star dimensions are fully denormalized, snowflake dimensions are normalized to some extent, because of the normalization only we'll see one table got split into more than one table. So this got split into more than one table. So this is what your dimension modeling, star schema and snowflake and multi-star. So now that we know, okay, star, snowflake and dimensions, okay, now we have to go detail. So this is where we stopped yesterday, okay. So now when I'm creating a dimension table, okay, so every dimension table, okay, what type of columns you will have. If you take any dimension table, okay, that we have seen a couple of sample tables. So when we are creating tables in a database, we can, to easily identify, we can follow some standards. So to identify which is a dimension or which is a fact table. So first I am looking at the dimension tables. Okay. So here in this example, this is one of the original data. Okay. And where the dimension tables are created. So in these dimension tables, you can see, okay, to easily, so I have some 1000 tables. Out of 1000 tables, which is a dimension, which is a fact, to easily identify. So when I am creating the tables and I am creating, okay, following some naming convention, okay, in every table which is ending with D, okay, is called dimension table. Okay, even if somebody gives me a table, by looking at the table I can tell whether it's a dimension or a fact. If any table which contains all numericals, measures, that quantifiable information, generally you can say that this is a fact table. Any table which contains all the attributes, textual attributes, okay, your name, description, this, that and all, okay, then that you can call as a dimension table. Okay, so now this is one dimension table example. Every dimension table if you take, okay, will have this kind of descriptions and all. So generally these descriptions you cannot sum, okay, you cannot make average. If I say sum of category name, if I sum of account name, you will not get anything. But in the fact table, you have a quantity, okay, a price. If I say sum of quantity or average quantity, or I can say min, max, okay, prices, all that mathematical calculations you can do on the fact table column. But in a dimensions, we generally cannot perform mathematical calculations like sum and all. So that way also you can define fact table contains all the numerical columns, numerical information which you can apply mathematical calculations. Okay, just for example. So now when I am building the dimension table, okay, so after building the dimension tables, okay, I will create. So what are we going to do? We are going to load data into these dimension tables. Okay. So for that we have to create a table. So what dimension contains we know, but when we are creating a dimension table, what are the components we will have in every dimension table? Okay, that we have to go detail now. So that is something like components of your dimension table. Okay, so every dimension table when I am creating, okay, we will create, okay, some columns, something called surrogate key, something called natural key, okay, something called dimensional attributes, and ETL specific columns, hierarchies, levels. So these hierarchies and levels generally important for the reporting people, for ETL people not required. Okay, but still, so these two topics, hierarchies and levels, will be discussing in a OBE classes for the reporting people, but remaining all everybody should know. And at the same time, once you create a table with all these columns, when you are creating a dimension table, when you are loading data into your dimension, how do you load? Because I have a table, I want to load. How will you load? Okay, are you inserting or deleting, inserting or updating? Okay, there should be some strategy. So that is called dimension load strategy. So there are three loading strategies which are called type 1, type 2, type 3. Also currently in a recent trend we have something called type 4 and also type 5, type 6. I will give you what is 4, 5, 6 just for information sake, but not that important. So nowadays very huge data projects we follow 4 and 5, 6 also, but you should know at least 1, 2, 3. So 4, 5, 6 is maybe at end if you know what is this one liner, that will be sufficient. So now to understand these two topics, what columns will be there in a dimension, how you load data into data warehousing, okay, these dimension tables, I will try to recap, okay, all at together so that you will come to know, okay, what is this, and after that, okay, once we finish that, okay, we'll go detailed about, okay, types of the dimension. Let's say we have seen 100 dimension table. So each and every dimension table, every table has its own name. Okay, to easily understand the behavior of every table, okay, every dimension table will call with some names, will group them. Okay, so this is like a slowly changing dimension, okay, this is confirmed dimension, this is this dimension. So this is practically not required right now, but for interview purpose, okay, this is very, very important, especially for senior people. Okay, you will get minimum 4, 5 questions. What is confirmed dimension? What is junk dimension? Like these kind of questions. It is all theory, and initially I'll give one liner what this dimension, but in our regular classes when we are going, so we'll be learning, working on all these dimension tables. At that time on regular basis, I'll give you practically how this table looks when you call this as this table, because even if I tell all theory, you may not understand unless you see practically. Okay, this table, when I have this kind of data, I will call it as this table. So practically when you see, you can easily understand. You don't need to by heart the definition. Okay, initially we'll go what is what. Then in advance, okay, in the next phases, okay, we can go detail about the type of dimension. So now I will move on to, okay, these dimensions and the load strategies, okay, and what will be there in a dimension table. Very, very important. And if you, this is the entry point if you want to jump into warehouse, either a reporting or a ETL. So this is what previously all theory, star schema, snowflake is interview purpose. Okay, first interview question generally you may start thinking like what is star schema, what is snowflake star schema, and what is the difference. Okay, which model or which kind of technique currently is followed in your project. There are all couple of questions from the topic. So now this is a very, very important, okay, interview purpose, practical purpose, or all the purpose. Okay, so now what we'll do, I'll take one scenario. So to understand what are the components we'll have and what tables we will have, and to all together work on. Okay, so this is, okay, every dimension table when I am creating, so there are the columns will be there. We'll see what these columns and why we need these columns, what is extra and all the story we are going to discuss now. Okay, so to start with, I am going to first with load strategy. Okay, now I have a table, I have some transactional data in the left side. So I have to take the data and then load into warehouse. How you load, okay, and how you are going to keep data in your target table, okay, and that is strategy. And there are 3 type of strategies, and high level 4, 5, 6 are there that we'll discuss later. So commonly you should know 1, 2, 3. What is type 1, what is type 2, type 3. Okay. So what is this load strategy? Let's take type 1. Okay. So you have data, there is a bank started. Okay. There are some customers who joined in a bank. They have taken new accounts. Okay. So this data I want to take from the bank system and put into our warehouse. So when you are taking and putting into warehouse, okay, if you are using type 1 strategy or a type 1 method, so 2 activities. New record you have to insert, changed records you have to update it. Okay, so there is a new customer joined. Okay, take and insert into your data warehousing table. There is a customer already, but his address has been changed. You will take and you also go and update it. Okay. So because of this, okay, there will not be any history maintained. Okay, you will not have history. Okay, we can decide, but why there is no history, still why we have to. So there are some scenarios. Company may not require their historical information. Okay, there will be some scenarios. Okay, and type 2. Type 2 means, okay, so whatever we are discussing, everything I will give you notes. Don't worry about the definitions and what will be the interview questions in that topic and how to explain a word, because generally sometimes you know what is what, but when you are explaining an interview, how easily you can frame it, because if you by heart the textbook definitions, it will be very tough to by heart, and also it doesn't look natural when you are explaining. Generally, when somebody work in a real time, when somebody asking, you will feel like you will give a natural answers. How a natural answer should be. So that I will give in a notes. That don't worry, because I can dictate notes, but it's time waste actually. That's why I'll give a notes. Don't worry. We have everything readily available. Okay. So in the type 2, new record again will insert, but changed record, okay, again will insert, because in the type 2 will maintain history. We'll see how this works. Okay. So type 1 means a new record insert, changed record also, changed record update, but in the type 2, new record insert, both are same, but changed record also will insert here. After that, we'll do couple of activities. Why we'll do, we'll see now. Okay. So type 1, there is no history. Type 2, there is a history. Okay. Now there is another method called type 3. Type 3 is a partial history. Okay, it will do it a different way, and generally you will see, commonly you will work on type 1 and 2. Type 3 is very rare, but interview purpose we should remember. Okay, so now let's get into detail about what is type 1. So now we know type 1, new record insert, change record update. So now let's take one small scenario. Okay, assume that there is a bank, okay, started. Okay, so just I started bank today only. Okay, the first day. Okay, and day 0, this bank is giving, okay, some insurance and also insurance policies, and also giving some credit cards. Just assume that. So day 1, okay, bank, yesterday we started 0, nothing was there. Day 1, so these are all our OLTP systems. Okay, your live systems. So there is one customer taken a credit card. Okay, and there is one customer taken an insurance. What we do data warehousing means we'll consolidate all the customers and put into one table in a warehouse. So that is our, so right side is our data warehousing. Okay, and this is our tables information. So when you apply, when you fill your form and apply your new account in a bank or whatever you do, they put your information. So you are getting an account means your information is there here. So this data I want to take and load into warehouse. When I am loading data into this warehouse, you choose whether you want to type 1, type 2 or type 3, because 3 methods we have. Currently we are going to see how we do in a type 1. Okay, now question is, who will do? Type 1 says theoretically, new record insert, change record, update it. But who will do? Using any ETL tool, let's say Informatica. So let's take Informatica. Using Informatica software, you extract data from this table, and from this table, identify whether this record is a new or not, which using Informatica as a ETL tool, then insert it. If there is a change, so who should identify whether it is a change or not? Your Informatica software. So you should write a program in Informatica to find out whether it is a new record or whether it is a changed record. Okay, then once you identify, go and put that information into your target table. So that is what, as a ETL developer, you will be developing a code in Informatica, or if you are using any other ETL tools, you will be developing that code. That is what ETL developer duty. But how we do theoretically, okay, we are going to discuss in the type 1, okay, what you are supposed to develop in your Informatica mapping or using ETL. So we are going to discuss now. So type 1 means we know new records insert, change record, update. So in this scenario, we have 2 records in these OLTP systems. Okay, so because these are new information, so new information, what I am supposed to do? Insert into target table. Simple. So I am taking this data and then inserting into this target table. So I have taken this information, so I will insert. So you write a code in Informatica to identify which is a new record, and a new record you should go and insert. That all code you will be writing in Informatica. Done. Okay, so okay, I1, okay, the Ginger, okay, USA, and then C1, there's another customer staying in Canada, are taken and then put into the table. Over. Then couple of days later, okay, day second. So what happened? Okay, there is new customer joined in this credit card. There is a new customer taken credit card in the bank. Previously we have 2 customers. So again, one more customer taken new credit card in this bank. Okay, so we had 2 records there previously. So here we have 1. So these 2 already there, and this is a new customer joined in a bank. Okay, in a credit card. So what we have to do in the type 1? New record insert. So you will write a logic in Informatica to find out whether this is a new or. So we will be learning in Informatica how to identify them. So that forget about technically. So theoretically, now I know that this is a new record. So new record, by default I need to go and insert. So I have taken and then inserted. So it will be continuing the same way forever lifetime. If you decide to type 1, go and take the data. If it is a new insert, that's all. Continuously new record will be inserting. So in this scenario, okay, after day 3, okay, so what I am doing, what I have done, okay, this customer requested, okay, I am moving from USA to UK, please change my address. She requested in the bank, so she filled application form and then given in the bank that please change my address. I am moving away from the USA to UK. So bank people, we know in OLTP, what do we do? We'll go and change. If any change, we'll go and change it. So we'll not maintain any history here. So previously this customer was staying in USA. Okay, and then also you see the customer status means H means hold. Just example, they are not allowing her to do any activity, is on hold. And now she requested, okay, and to change my address to UK and also please activate my account. So this is the change we can see in a bank. If I go and see my online bank system, I'll see this information. Okay. So now in this case, we have already this customer I1, okay, and previously we have USA and then H means hold. That information we already have it. But this today and day 3rd, what happened? There is a change in the behavior of the customer C1. Okay, previously UK and USA, now it is UK because there is a change. So as per the change, what we are supposed to do? Changed record, we have to update it. So you write a logic in Informatica to identify which record has been changed compared to the previous. Okay, go there and then just simply you also update there. Okay, so this is the change. Okay, UK, and take this data and you also update as it is in your warehouse also. Okay, so UK is there, I'm going and directly updating it. So that's why the changed record you also update it. Okay, now typically if you observe, whatever we have in data warehousing, both are same, but the only thing is it is consolidated. Here some customers it is consolidated. Okay, but here also we have latest, there also we have latest, but there is no history. So that's why type 1, if you see, new record insert, changed record update. Okay, but it will not give you historical tracking. If I go and see either this table or this table, if somebody asking, please tell me what is the previous address of this customer before UK, nobody can tell in any of the table. So in case you do not want historical tracking, then only we'll go for type 1, because it will not. So it is not that I am not dictating you always go for type 1, it is your wish. I don't want historical, then I prefer, because I can save some data. Okay, but in case you want historical, it is not advised to come for the type 1. If you want previous information, since it is not giving, so you never come to type 1. Okay, so this way you take any. Okay, this is how it is working. So now in one scenario, if there is any change here, if something change here, we'll take all that and then dump here. Okay, always will new change and it will be continue like this. New records insert, change record update. Because of this, no history. Fine. This is how type 1 works anywhere in the world, not only here. This is a predefined fundamental. Anywhere in the world, type 1 means it should be like this only. Done. Now that type 1 has some limitations where I cannot have the historical information, it is a big problem, because generally we would love building warehouse for historical tracking only, because there is one customer, okay, staying in, let's say, Pakistan. He did some lot of illegal activity and then he came to India and then he is transferred that money, is enjoying here. So I want to know from where he came, how long he stayed in Pakistan, before staying in Pakistan, what activity he has done, from where, which account the account got transferred. Lot of things. People will do lot of analytics in a warehouse. That's why without data warehousing, a bank or any bigger organization, they cannot run their day-to-day business. So the moment, if you see any bigger organization, every company CEO, as soon as he wake up, he will be looking for a data warehousing report only. He will not even look for coffee tea. First, as soon as he wake up, people look for the report only, which comes from the data warehousing. So how business happened, what happened yesterday. So that's why it has becoming very, very crucial in day-to-day life of the people. Okay, so fine, type 1, so you decide. Okay, if you don't want history, only come here, otherwise come here. So I'll tell you why sometimes you can go for okay, sorry, I didn't realize that you are getting this. Okay, so say for example you are running a bank. Okay, you are capturing customers and their food habits. Okay, you are a bank, so what you have done, there is a bank is providing an online, okay, screen, so to update anytime whether your food habit change or your drink habit change. So this guy doesn't have any work, every day going online. So today I prefer biryani, and next week, okay, he changed the food habit to have some idli sambar, or then he is right now is drinking one liquor brand. So tomorrow he changed to different brand, and later he changed to different brand. He just keep enjoying all these brands. So every time whenever he is changing his food habit, so he will go and update in the internet. So that will come and update here. So if you are taking this data and then putting into data warehousing, okay, if I keeping my all history, let's say this guy changed the liquor brand, okay, 10 times in 1 month. So if I'm Okay, sorry. Okay, so here, if I keep all the food habits, okay, so generally bank, they never care about the customer, okay, previously what type of brand he was having, okay, what type of liquor he is drinking, because they don't care. But they need only current brand, because a bank, okay, you did lot 1 million transaction in the bank, okay, because of that they want to offer some dinner party or offer some gift. So they can request, okay, because generally banks will offer lot of gifts and dinners to the privileged customers who are making lot of business, okay, bring lot of business to them. So in that case, if I want to offer a drink, I would like to know what is his latest current liquor brand, okay, which is his favorite. I don't bother about my previous, where in this bank. So that's why if I'm building that customer, okay, habits or behavior, so in that table I don't need historical. If I know the latest, that is enough. But same data, if I'm building a warehouse for a liquor company who are manufacturing the liquor, for them it is very important that every customer, how frequently they are changing their brands, because so if somebody not moving away from this brand to another brand means they are lost the interest in this brand. So if they want to know why this, okay, people losing the interest in my brand, what is something new in the other brand, what is good in the other brand, so that they will try to incorporate those in the new the whatever brands they are offering. So that way the scenario will change from the business to business. Sometimes some information not relevant, okay, to maintain history for one company, maybe other company may require, for that they have to maintain history. So it is all the business strategy, whether you want type 1 and type 2. There is no your or my wish. It is a completely company wish, for which they want history, they don't want history. Okay, so now this way, when you are building a type 1, it will be easy. New record insert, change record update. Technically, if you know Oracle, it is a merge command. Okay, it is a upsert command, update else insert. Okay, new record insert, change record update. But now, if it is a type 2, because now people decided that I want history. So whenever you want history, you need to go for type 2 only. The type 2 will help you to get all your previous historical tracking. Okay, for that, what we'll do, we'll see right now. Okay, this is completely, forget about type 1. If you are doing in a type 1, we'll do that way only. So now I have decided to do in a type 2. Okay, because type 1 is not giving any historical information. New record inserting, change record updating. So forget, if you are deciding, yeah, tell me.
Yeah, like I have a question here.
Yes. Yes.
So, yeah, in type 1, you're telling that like no history is maintained, right?
Yes. Yes.
So, like, how come like in when we are going to a bank, okay, and when we are requesting for an address change,
Yes.
we'll not tell to bank, right, that don't maintain my history, or else like delete my old history, keep my new address only. We'll be not telling, right? So, who will be deciding this thing?
No,
Who will be
bank.
taking?
Yeah, bank when they are doing automatically. So this is your original bank. This is the warehouse. So when you are requesting the bank, automatically they will go and update the information. In the bank, they never maintain history. But when you take the data and then putting into warehouse, whether you want to, whether you are keeping historical data in a data warehousing, or whether keeping only latest information in data warehousing, that we will decide. Okay, the business people who are the one going to analyze the data on this, okay, they will decide whether you You want to keep historical or non-historical. So that business people will, bank manager, person who is going to use, means like your bank CEOs, managers and branch managers who are giving the requirements for the data warehousing, they will decide. And we will follow that instructions to whether to maintain history or not.
Okay. So like whatever the changes which we requested, it will be enabling only in OLTP system, not OLAP system. That's what you mean, right?
Yes, yes. So, no, once the changes are enabled, we will take from here. See, if you see this slide, left side is the OLTP system.
Yes.
Okay. So now you went to bank and then asking for, okay, change my address. So immediately in a bank, they will go out to the bank, whatever system they are accessible, they will go and change it.
Okay.
They will click the update button. Immediately this will get replaced with whatever new information you have given.
Okay.
Okay. So this data, okay, and maybe every day once or 2 times or 3 times, we take this data, okay, whatever, let's say insurance left side boxes are there, from here we'll take and then put into warehouse. So when you are taking data from the left side system and putting into warehouse, so during that phase, we will decide whether we'll identify whether this is a new, okay, changed address or previous address. So we'll identify whether there is any change or not. Then I will go and try to keep into target table, that is a warehouse. When I'm keeping this data in a warehouse, I will decide, means your business people might have already told you, if there is a change, okay, are you going to maintain history in a warehouse or you are going to just update it? So that will decide, okay, technically, well, you are putting, we will write a code technically whether to keep historical or only update the data. So that in a ETL development, we do that activity.
Okay. Okay. Thank you, sir. Thank you very much.
Yeah, okay. Okay, and now we are talking, so type 1 clearly there is no history, and the type 2, okay, again, so the question was, so who will decide type 1, type 2, means the people, whoever is going to view the data, means your top management who is telling that I want warehouse and then in this I want data, so those people will give you the requirement, and for that we will write a code. Okay, so now in the type 2, okay, so now type 1 no history. So now if it is history required, and how type 2 will do, we'll see right now. So now again, okay, there is a bank started. There are only 2 customers, okay, C1 and C2, and data warehousing is empty because first day there is nothing. So now we have to take this data and load here. So in the type 1, type 2, first line is same, new record insert, because this information we don't have here. So obviously you have to take and then insert into warehouse only. Okay. So now, as usual, I can go and take this data and insert into your data warehouse, the right side, new record insert. Fine. After few days, okay, the customer address, the C1, previously she was staying in New York, so now she changed the address to Boston. Okay, so now since there is a change, it is a type 1, what will do? If it is a type 1, what will do? I will take this Boston and then update here as a Boston. Both will be same. Changed record will update there. Okay, now. But in the, since I want history, that's why I am going type 2. So in the type 2, what will do? Changed record also we will insert. Okay. So this customer, now there is a change in the address. I will take this data and then insert as a new record, okay, into this table. Okay, as per the type 2 strategy, new record insert, change, there is a change, C1, okay, Austin and Boston. I am taking this data and dumping, putting into this table. Previously C1, that is as it is, I am not disturbing. Second, C1 also there, I am not disturbing. C1, there is a change. So when there is a change, I am going and then inserting into this table. Okay, fine. When I insert this, I will have my current and historical. What is the current address? Boston. What is my previous data? Previous address? New York. It is there. You are happy. But what is the problem is? So generally, if you remember star schema, snowflake star, every dimension table, okay, will go and join with the fact table. Primary key, foreign key. Okay, even previously you have seen, okay, in dimension table primary key, okay, will join with your fact table foreign key. So C1, C1, 2, because every fact should be related with the dimension table. For that, in this table, okay, so far we have not seen any problem. Okay, and because if you see any our previous tables, okay, C1, C2, I1, lot of tables are taking here. I can create a primary key on this column. Currently, I didn't even think about, because I don't have any problem. I can create a primary key. But in this case, when I'm keeping data like this, can I create a primary key on my customer ID column? So I cannot create a primary key on a customer ID column because it is duplicated. Same information I'm repeating twice to maintain my historical information. So that is the reason when we are creating the dimension tables, okay, and generally for type 1s you will not have any problem, okay, but considering all these current, future, all the problems, when we are creating a table in a data warehousing dimension table, okay, what we'll do, we'll create some additional column along with this information. Along with the information what you are taking from your OLTP system left side and keeping into target table, to accommodate this information into this table, minimum we need this column. Addition to these columns, okay, we will create some columns, okay, those columns which you have seen previously, surrogate key, natural key, lot of things. Okay, so that's why, so this table is not going to help me to maintain my type 2 information. Okay, so that's why what I am doing, I am creating same information only. For that I am creating some extra columns. Okay, so what those columns? Previously we have customer ID, name, marital status, address, okay, status. These are all the columns, we already have it. But to solve my problems, whatever, we know only one problem. In future you will get lot of problems. Okay, to address or to solve all those problems in one shot, when I am creating a dimension table in a data warehousing, okay, so we'll create some extra columns, okay, which are called, the first column which is called surrogate key. We'll see what is surrogate key, and we'll create one extra column called current flag, and effective from date and effective to date. So these are the additional columns we will create in every dimension table, okay, to address the current or future any problem, any technical challenges to address. So what are we going to do in this? Okay, so whenever I am going to keep, let's say previously we already have this data, two customers we had, so already we have this information. So now since there is a change, okay, whenever there is a change, okay, what are we doing? We are inserting it. Because of that I am not able to use this column as a primary key. So that's why when I am inserting data, taking data from here to here, okay, New York, Chicago, I am keeping the data into this table. In addition to this information, we have some extra columns created. So in those columns, okay, in surrogate key column, okay, the column is called surrogate key, I will generate, okay, some continuous serial numbers. Okay, so this data we have put here. Along with this data, when you are taking the data from here, I'll keep all this data in these columns: customer ID, name, marital status, address, and status. We are taking directly from here. In addition to this, we have an extra column called surrogate key. In this column, I'll keep 1, 2, 3 some numbers. Okay, so generally the surrogate key columns, we'll see why it is called surrogate key. Okay, how it is going to help in the next okay, few slides we can see. So when I'm keeping some numbers into this column. Then in the current flag column, I'm keeping some values like y or n. What is y? What is n means? To indicate that, okay, this record currently, because we are still in day one only, because we are not gone to the day 2. Okay, in the day 1, whatever customers we have, these are the customers, okay, we are keeping here. So I'm keeping some numbers, random numbers, 1, 2, 3 continuous numbers, unique numbers. So what is the benefit, we'll see later. Apart from this, in the current flag column, I'm keeping some flags saying that y. So the y indicates, okay, latest record, current record, okay, and so because, so in the OLTP systems, whatever you have, there is no change, and first time we have, so same information I'm taking. So for this customer, this is the latest record. For this C2, this is the latest record. So the current flag y indicates that this is the latest record. Then in effective from date and effective to date columns, okay, I will maintain effective from date. So you are taking the data and keeping into this table and in this column. Okay, what is, since what time this record information is right? Okay, because he joined in a bank day 1. Okay, so effective from date, from day 1 onwards, okay, this record information is right, effective. How long to date, if you see, how long this guy will be staying in New York, how long the customer account will be active, okay, that we don't know. So that's why in effective to date, okay, either you can keep blank, null, or you can keep high date. High date in a calendar, what is it? If you take a calendar, what is the biggest maximum date in your calendar? 31st December 9999. That is the highest date. So you can keep, okay, any date which you cannot imagine. Okay, generally that is called high date in a data warehousing. Okay, I just put 999. You can say 31st December 999. Or you can keep null, which will nobody will reach, or which will be not falling on your business date. Okay, so that's why whenever you are building a type 2, loading data into dimension table in a type 2 method, take the data from here, okay, and then okay, along with the data what you are taking and then putting here, along with this, okay, you generate surrogate keys. These are nothing but 1, 2, 3, 4, 5, 6 continuous unique numbers, and keep the current flag information y, because this is the latest, and effective from date, effective date. So when you have inserted, how long this will be right, I don't know at this moment, because this is the right information for me. Done. Now after some time, what happened? So this is over. Okay, we have the data and everything is fine. After few days later, what happened? Let's say after 5 days later, so now this customer asked to change the address in a bank. She went to bank and then given a form, and then address being changed, updated in a bank, and now the address has been changed to New Jersey. Now the customer now changed the address to New Jersey. But what is the previous address? New York. Okay, now I'll write a ETL logic to identify whether the new customer or change or anything. So there is no new customer, but there is a change in the address. So now if it is a type 2, what are we going to do? Changed record also we have to insert. So now when I'm inserting this, what I'm going to do? I'm taking that changed record, okay, and then again insert. Previously also I was inserting, okay. At that time we had a problem because I don't have a primary key. I cannot create a primary key on this. So this time also I am taking that entire C1, okay, JSON and New Jersey, this record, and inserting as a new record here. And along with this, what I am doing, okay, I am generating a new number because it is a new record. So this is you have inserted. So I am keeping one, putting some new unique number 3. Previously 1, 2, and I am keeping 3. You can, so how to generate this number? Easy. If you go to Oracle database sequence, it will continuous 1, 2, 3 number like this will generate. Or Informatica will have a support of generating some numbers. We'll see how to do it in Informatica. That is what your final ETL developer role activity. Okay. And now for customer C1, this is the latest record. Okay, I am saying current flag Y. And when you have inserted on day 5, how long she will be in, okay, New Jersey and then with unmarried status, I don't know. That's why I'm keeping here. So I've taken the data. Technically, I'm inserting as a new record, generating a new surrogate key. Current flag I'm keeping Y because this is the latest now, and effective from the day 5 and effective to date. How long? I don't know. But now if I keep this, one advantage is, since I need a primary key, primary key in this table, previously I don't have a column to define a primary key. Okay, and customer ID I was not in a position to use as a primary key. So that's why we are introducing a new column which is called surrogate key. I'm keeping 1, 2, 3. So now I will create a primary key on this column. So if I create a primary key, if I define a primary key and surrogate key column, don't have any problem because it is 1, 2, 3 continuous numbers. So when I'm inserting the data, we will generate. So nobody will give you 1, 2, 3 numbers. We will generate the numbers and we'll keep one unique number for every record in this particular column. And because of that, I can define this as a surrogate key, primary key. So now, what is a surrogate key means? A surrogate key is a primary key column in your dimension table. So why it is surrogate key called? So now, generally what is surrogate key meaning? Let's say there is one child, okay, it doesn't have any mother, father. So there are some parents, okay, acting parents who are going to take care of this person. So those are called surrogate father, surrogate mother, like this. So here also, we have a column, customer ID. It is supposed to be primary key because customer ID, let's say good student. Student ID, roll number should be always unique. Customer ID should be always unique. Okay, I cannot keep same customer number, account number to same people in a bank. Okay, so generally those are supposed to be primary keys, but because of repetitive nature, so same information we are repeating. So that's why I'm not in a position to use customer ID as a primary key because I'm repeating the data. So that's why I'm creating one dummy column. In that I'm keeping 1, 2, 3, 4 continuously. That I'm using as a acting primary key for my dimension table. So that's why these are called surrogate keys. Okay, this will be the primary key for any dimension table in data warehousing. Okay, acting primary key. So now generally sometimes in interview they will ask you, okay, generally what data types will use for the surrogate key? Always use numerical columns for the surrogate keys. You can also create character, okay, but we still prefer numerical only because in a database, if you see the performance, always numerical data types will be performing better than the other columns. If you see the order, top numerical, then char, then varchar and date. So since we'll keep lot of volumes in the dimension table, then we'll join with the fact tables and all. So the numerical will be performing faster. That's why data warehousing, okay, proposes that you create a surrogate key with a numerical column and generate 1, 2, 3, and you can define as a primary key. Okay, so that's why surrogate key is a primary key column in a dimension table. Generally, we will have 1, 2, 3. We will generate those numbers and load here. Okay, and means one problem, primary key problem was solved because of I have created a new column. Then, if you come here, previously I inserted that it is having Y because at that time it was the latest, and now I have inserted one more record. This is also Y because this is the latest. You are just inserted only technically. If you leave it, what happens? Generally, why we are using this current flag? Current flag will tell you that out of all these records, which is the latest record, which is the old record. So right now we have 2 Y. So it is actually wrong. So in a type 2, new record insert fine. Changed record also insert fine. If you leave it, there is a problem because both are having Y. So that's why whenever you are inserting a new record, changed record insert. Hello? So I'll take 5 minutes and stop. People are okay. So now if I change a record insert, if you leave it, there is a problem. So that's why version old records. What is this means? Means again you have to develop a code in a ETL to go and change this information to something else. What we'll do here, I will go to, okay, after inserting this, I will go to previous records. I will make them N, okay, because that is no longer latest record, that is no longer current record, okay. Then if you go to that effective to date, what I am doing there, now this record is no longer valid, but during what period to what period this record was right, or in other meaning, during which period to which period, okay, she was staying in New York, just for example, okay. So D1, since how long she stayed in, or which period up to which date she stayed into New York, she requested to change in the address on the day 5th. So up to day 4th, okay, she stayed in a New York City. That's why effective to date they are putting. So now if you make these changes, it will be completely clear. So I can address. So primary key solved. Then if somebody coming and asking, can you please tell me all the customers' latest address, latest information, I can go and write a query. Select star from this table where current fly equal to y. If I write a query current fly equal to y, so it will give you all latest information only. Okay, latest information you can get. Somebody coming and asking, okay, in day 3, what is the address, whether a customer got married or not, I want to know for the customer C1. So you can still go and select star from this table where day 3 between effective from date and effective to date. So it will go and directly take you that location. So during this period, what is the status of the customer? Okay, let's say example, I have a product. 1 year back, product laptop Dell Inspiron having warranty period 1 year. Later they removed it. Okay, there they increased the price, lot of things. So I want to know in October 2013 for this Dell Inspiron whether you have a warranty period given or not. I'll go to this table, select star from this table where date means October, okay, 2013 between effective from date to date. Okay, so you can see the historical, all the information, current information. You can also track at what period, what is the status, what is the information of that particular customer. Okay, so that's why when you are building the data warehousing, we'll have the normal columns 1, 2, 3 which you are taking directly from the OLTP system. We will have the surrogate keys, we have the current flags, and we'll have the effective from to date, from date and to date. Okay, and it will continue like this. Okay, then we'll have a couple of things to discuss. Okay, that we'll discuss tomorrow. So generally this customer ID, okay, is called natural key. And what is natural key? What is the difference natural to surrogate key and all? We'll see tomorrow. We'll continue that.